Yeah, yeah, yeah. That'd be great. Okay, let's see. Okay, let's get started, everybody. We are at the end of week 5. Happy Wednesday to everybody. We're gonna finish functions. This is gonna help us out with the next homework, the robot cat. All right, so just give a couple announcements real quick before we talk about this next robot cat. There are a couple assignments due. I believe the HTML weather is due tomorrow. Let me see, when is it due? Yeah, HTML weather, this one is due tomorrow. It's pretty much the same thing as the previous weather one, but we're gonna format things in a table. And I realized that we didn't really give a head start on this assignment. I wanted to see how far folks can get. So, tonight I'm probably gonna record a optional video, like maybe just a quick 10-minute video giving folks a head start on this. Right, but pretty much the HTML weather is asking folks to make a table. Right, so we did this in the lesson 9 over here. Lesson 9, towards the very bottom, we did a table over here. Right, so there's one example of a table here, right, which prints out two columns, classes and titles. And then we did another example here. We did this last week. Right, and in this example, we use a F string instead. Right, so this is probably going to be super useful for your weather assignment if you can format it using an F string. The reason why is because the weather data can be pulled into these braces, right? This is where things can be interpolated. Right? For example, I can interpolate this variable name, right? And then it'll, when I run it, it'll put Alice inside that cell, right? The table data item. And so you can think of this as the weather assignment, right? In terms of that assignment, you'd be pulling from the weather data, right? So yours would probably look like weather and then something, right? So something in here. I'm not sure which keys people are focusing on, but yeah, you can interpolate the dictionary values into these F strings. So that's the hint for the assignment. I'll record another video tonight. Okay, so yeah, that assignment is due tomorrow. We have another assignment that's called RobotCat 2.0. This is the same exact one as the very first week. Right, on the very first week, we did a RobotCat, and this time we'll do it again. We'll do it again, but we'll use functions, which should help out a lot. I already have it downloaded into here, so this is the next assignment, RobotCat. Right, it's pretty much the same thing. Right, just draw this, but we're gonna have a couple functions that will help folks get this done. Right, so by the end of today, folks might see how to draw this in about 10 function calls. Right, there are like 10 shapes here. Right, one square, 3 triangles here, another 2 squares, and then triangle, 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 triangle. So yeah, there's about 10 shapes, right? Think of this as, using 10 function, like calling a function 10 different times, right? But between those function calls, you're moving the turtle, right? So maybe draw a square here, and then move the turtle and draw a square, and then move the turtle again, draw a square, right? Move the turtle again, draw a triangle, right? So that's pretty much what the goal is today. We should be able to do this. It's gonna be pretty cool. So that's the intro for this assignment right here, due next week. All right. We should jump into the rest of the functions lesson. Once again, this is one of the most important topics in my opinion. One, because the midterm and final is 100% reliant on understanding functions. Most of the questions will be, hey, write a function called something, right? It's going to look like this. So I'm going to scroll down this lesson right here. Right? An exam question can look like here, right? Example problem. Right? It's pretty much going to say something like, write a function called power of that takes two arguments, right? And then these two arguments, and then the body of the function should do this. Right? That's all of the exam. It's going to ask you to write like 6 or 7 different functions. And we did this in the lab too, right? Over in the lab 10, right? These are example exam questions. So I would recommend maybe practicing this again, right? Like maybe deleting these cells and then trying it over again. Right? Okay. Another reason why functions are very important is because it gives the programmer a way of building Legos. If folks are working in the industry, some of the times you'll find yourself writing functions that your coworker can use. So your coworkers might depend on the reliability of your functions. Right? You can think of it as you're writing a library, and then your coworkers will pull in the library to use the stuff you just wrote. And so functions are very important. Right? They help us divide the program and make it easily more readable, and it allows us to reuse things over and over again. Okay, so yeah, just a bit of motivation. We got all the way down to return values, I believe. All right, so let's continue from here. Let's start off with this example problem, right? A possible exam question. So this example is we're going to rewrite a function that's already given to us. Right, so you might have seen this function in Python. Function Python. I'm going to go built-in functions. Right, we're going to rebuild the wheel. In this case, it's going to be the pal function. So there's a function called pal right, that takes a couple arguments, and it's going to return some result. If folks are wondering what this function does, it's pretty much like this right here. Like here, I'm going to pull up a terminal. You can do this in a cell as well. Right? You can do this in a cell and press play. It's the same thing. Right? But there's a function called pal. If you've taken a math class, you can think of this as a power of, right? Like what is 2 to the power of 3? Right? 2 to the power of 3 is 2 times 2 times 2. So this gives us 8. Right? And then let's see what pal of 2 to the 4 is. Right? 2 times 2 times 2 times 2 should be 16. Okay, so we're going to rewrite this function, right? Like someone wrote this for us, which allows us to call it, right? So this is already provided in Python, but we're going to rewrite it. So yeah, an example problem is it's going to say something like, write a function called power of, right? That takes 2 arguments, right? And in this case, sig and power. Right? So right away off this first sentence, right, we should be able to implement a skeleton. Right? We should be able to write the function skeleton. So let's do that. Right? Write a function called power of. I'm going to go down here. Right? So it needs to be called power of. Okay, so there we go. We just defined it. This is the name of it. And the question asked for 2 arguments, 2 inputs. So let's see what they want to call it. It says takes 2 inputs, sig and power. Okay, so right away we should be able to put those 2 inputs here. Okay, so sig and then input. Wait, input? No. I think it was called something else. Power, my bad. Power. Okay, there we go. So we got it. There is our function skeleton, right? The function header. Okay, let's see the rest of the question to see what it's asking us to do. So it's saying the function should calculate and return this value, right? The first input to the power of the second input. Okay, so let's go ahead and do that. All right. One easy way we can do it is by using something called a Python power operator. Right, the power operator, if you click on this link, it's pretty much going to introduce a double asterisk. All right, it pretty much, if we do like 2 double asterisk 3, right, this is a power operator. Right? It's 2 to the exponent of 3. Right? And then similarly, 2 to the power of 4. This is 16. Right? So we're going to use this within that function. Right, so this should return something, right? It's calculating a number, right, with these 2 inputs. I'm going to store it in a variable called result. Right? Result is equal to the calculation. Right? In this case, the calculation is the power operator, right? Sig to the power of power. Right? And once again, these numbers are not defined until we invoke the function. Right? This is a general function that we haven't used yet. Okay, we do need to return something. Right, I'll explain that later, but right here it says it does need to return the value. Right, and it repeats it down here. Right? These are the specs, the specifications of it. So yeah, return the sig to the power of power. Right? In this case, it's going to be just return the result. All right, we'll talk about why we need to return this in just a bit. Okay, let me zoom in a bit. All right, I'm going to go ahead and run this. Okay, so I just ran the cell. Right, once again, it doesn't do anything, but it did define a function in the kernel. Right, the Python process now has access to this function, which we can invoke. So I'm going to create another cell and invoke it. Right, so invoke means to call the function with inputs. So I'm going to call the function, right, invoke, right, power of. In this case, we're going to maybe put in a couple numbers to test it. Right, like maybe I could try 2 and then 3. Right, so 2 will get substituted into sig, and 3 will get substituted into power. Right, and then the calculation will be right here. Right, so this should give us 8, right, which makes sense because this whole function returned the result. Right, so that this whole thing collapses to a single number. Right, it collapses to a single number. So if we do +1, this should give us, 9. Right, +2, that should give us 10. Right, so just to reiterate that this is a number. Right, it collapsed to a number because we returned it here. Okay, just more on the return statement. Right, what if we? Yeah, more on the return statement. So this function call actually returns something, meaning that we can store the result somewhere. Right, like. I'm just going to call it like something. Right? Something is equal to the power of. This line is saying, so the right side is evaluated first. Right? So we do the right side, and then the result will get stored into the left. Right? This is necessary sometimes because you might want to store a calculation for a future calculation. Right? We might need this number for later. So I'm just going to go ahead and run it. Okay, so I ran it. It didn't look like it'd do anything, but it did, right? We now have a variable called something, so we can go ahead and print the value of it, right? Like something is, I'm going to use an F string actually. Okay, something is something. So let's see. So this should give us 8. Okay, I hope that makes sense because we're returning a value which gets stored into here. The importance of the return statement, if we don't have it here, right? So I'm just going to comment this out. Don't do this yet. Yeah, don't do it because it's not what we want. So if we don't return result, let's see what happens. All right, so I'm going to run this. Okay, I just ran this cell. Right, so we have a new function. Right? We rewrote this, and it is doing the calculation. But if I go down here and run this cell again, it says something is none. Hopefully people see why it's none. It's because this function did calculate it, right? It did get the correct result, but the second the function ends, right, it forgets about it. It forgets about it because we never returned it back to the caller. So this is necessary so whoever called it can obtain that return value. Okay. I hope that makes sense why returning is important sometimes. All right. Okay, and just a little tricky thing. You don't have to do this, but what do you think is going to happen for folks who's good at mental math? Let me change this to 4 real quick. Okay. No, I meant 2. All right, this is going to be a tiny bit tricky, but 2 to the power of 2 is 4. What do you think is going to happen if I say power of, and then the first argument I'll say 2, and then the second argument I'll say this right here. What do you think? It's a little tricky. It's if you're good at mental math, right? Pretty much the Enzo says 16. Yep, yeah, it's 16, right? Let's see why. So you can chain functions together. So the right side is evaluated first, right? But in particular, the parentheses, right? We go inside the parentheses. So this is actually evaluated first on the right side. Right? Power of 2 to the 2. This collapses down to 4. Right? So in the Python kernel, it's going to collapse down to 4 like this. Right? And then 2 to the power of 4 is 16. Right? So just letting folks know that it is possible to chain functions. Okay, just a little tricky thing. All right, let's move down a bit. Designing with functions. So this stuff, this is a sneak peek into a few weeks from now. Later on in a few weeks, we'll talk about reading from a file. Right? We'll have an assignment called madlibs, which has a file. Right? People remember madlibs. If you're not sure what this is, it's I kind of grew up with this game in elementary school. But yeah, madlibs. It's a game where there is a story with blanks, and the one player is asked to fill in the blanks, right? Like say a verb, say a noun, and then those words will fill in the blanks, and it'll come up with a funny story. So you can imagine a story as a file. Right? So we'll talk about this in a few weeks, but I just want to give a sneak peek into reading files. All right, let's write a function that reads a file. Right, in this case, if we take a look at our directory, right, the file explorer on the left, folks see that there is a directory called files. Right, this is I'm going to go into it. Right, there's a bunch of files here. Right, in particular, we're probably going to focus on something called example.txt. Oh, I don't even have example.txt here. Do folks have a file called example.txt in this? No? Okay. Interesting. All right. So let's create a text file which we're going to read from. Right, so you can just right click. Okay, so first, I'm in the wrong directory. My bad. So check it out. I'm in the labs directory. I'm meant to be in the lessons. Right, so go into the lessons directory and then click onto files. Right. Okay, there should be something called example.txt now. This is a text file that we're going to be writing a function to read from. Right? So if we click into example.txt, right, it's just a text file that contains a poem. Now, people familiar with txt files? Okay, so I'm just gonna go over back here. Now, this is, once again, is a sneak peek. You don't have to really fully understand how we're reading from the file. The takeaway here is we're writing a function. Okay, so I'm gonna here write a function called a read first line. Right? For folks who have taken a Linux class, this is like saying head, right? The head of a file. In this case, we're gonna put a input here, right? Like maybe a name, a file name, right? This is going to represent a string, right? It's a string that represents the file we're going to be reading. So just to kind of document this so folks see what's happening, typically functions contain something called docstrings. Right? So if we scroll up a bit, you might want to read this a little closer. But yeah, in the example problem, we're going to be writing a docstring, right? This is a fancy way of saying description. Right? So for example, here I could write a description, right? A documentation description, right? Like maybe the purpose of this program, function, is to return the first line in a specified file. Right, so that's just the description. And then in the docstring, we typically describe the inputs and outputs. In this case, the input is a string called file name. Right, so we'd call it arguments. Right, in this case, there is one argument. It's called a file name, and this is a string that represents the specified file. Okay, and then so this is the input. Right, we also need to describe its output. Right, this way, the user knows what's happening. Right, so in this case, the output, right, we're just going to say it returns the first line in the file. Okay, so this is important actually. In the exam questions, this is the bare minimum for any credit. The bare minimum is to be able to write documentation inside of a function that describes what it's doing. It describes this, describes the inputs and outputs. All right. Cool. So you know what, before I even implement the function, right, let's kind of imagine what it's supposed to do. So it's not, there's no body in here yet. There's just a comment. Okay, I'm gonna make another cell. The purpose of this is if we were to read the first line, right, right, of some file name. Right, in this case, the file name is called example.txt, right? But we need to specify its path, so we know where to grab it from. Right, in this case, the path is relative to our notebook. So our notebook is right here in the functions. Right, the path can be relative. So if it were relative, then it would be inside of files, and then right, so that's like clicking into files, and then next is the example.txt. This is the path of the file. Okay, the goal of this function is to click into this poem and read the first line, right? This should return a string, right? In particular, it should just return this right here. This is example.txt. All right, so let's jump into it then. So this is not going to run yet because we didn't define read first line. So let's go ahead and finish defining it. Okay, once again, you don't have to fully understand this. This is actually a sneak peek into lesson files. Right, this is on number 13. So if folks want to get a head start into it, you can go a few lessons ahead onto number 13. So yeah, as long as you see that we're writing a function, you should be good. All right, so there's something called a file handle. All right, a file handle represents it's like a link, right? So like a link to a file name, right? In this case, we can do something called an open. Right? This is a function provided by Python. We could open the file name, right? And then you don't have to do this right here. This is called read-only mode. Right? This is like a safety argument. It's like saying when we open the file name, don't allow us to change the contents. So that's a read-only. All right, and then next there's a few functions, a few class functions, like read line. All right, we can say file handle dot read line. Let me see if I spelled that right. Yeah. This is a class function. You don't have to worry about it too much. What it does is it goes through the first line, right, and then it stores it. All right, so we're going to store it in here. I'm just calling it line is equal to this. Okay. And then next we can just return it actually. We can actually just return the line. But for safety, we should probably close the file. So there's a function called close, right? We could go, I think it's file handle.close. Yeah. File handle.close. Right. This is it's like clicking the exit button. Right, so just kind of explain what this is doing. Right. We're opening a file, right? This is like saying, okay, open this. Right, so we opened it, and then the next line right here, let me put these side by side. All right, so this first line is saying open this right side, right? So it opens in read-only mode, meaning that we won't be able to change the contents. But then this next line right here is grabbing the first line, right? Because we start from 0. So it's gonna grab the first line and then store it in this variable called line. And that's it. And then in this next line, close. Right? Close means to press the exit button. Right? So it's gonna press the exit button, and then we're gonna return the string, right, that we just read. So let's run this. So I'll run this definition. Okay, cool, it runs. And then this next line should finally invoke the function. So I'll go ahead and run it. And there we go. Let me zoom in a bit. There we go. All right, so there we go. Read first line. We invoke the function. We gave it the file name or relative path. And this is a string. Right? So we can actually store this string into something. Like maybe I'm just going to store into result. Right? Result is equal to the return value from this function. And we can print out the result. It's going to be the same thing. All right. Example.txt. Okay. Let's see. Once again, this is a sneak peek. Right? All we really need to know here is we wrote a black box that reads a file. Right? So we invoked it. This file name gets substituted into this here. Right? And then we're using that here to open up the file, and then we're reading it. Right? And once again, just a sneak peek into a few lessons from now, right? We can read multiple lines in a file, right? Like if we were to copy and paste this line a few times, right? Like, and let me rename this, like line 1, line 2, line 3. Right, so this is actually opening the file and reading 3 separate lines, right? It's going down. So if I were to print out, if I were to return line 3, right, this should give us something else. Right, so let's test this. So run, and then run this. Okay, there we go. So I just changed the function a tiny bit. Well, we see that it says violets are blue now, right, which makes sense because the the file looks like this right here. Let me put it up again. So we opened up the file, we read, this is line 1, right, and then this is line 2, and this is line 3. Right, so we're not reading the next lines. We're reading 3 lines and then returning the third one. So yeah, this is a sneak peek, right? It's going to be some pretty cool stuff. When we see the Mad Libs assignment, this is going to be a very useful function. Okay. All right. Oh, yeah. Which cylinder? Yeah. Oh, I don't have a cell here. Here, let me take a look at your. Let me take a look at your code real quick. Joe, I'll be right with you. Yeah. Oh, yeah. All right. Let's see. Joe in the Zoom chat. So a read line just moves to the next line if it is used more than once. Exactly. Yeah, read line, it seeks, right? It's seeking a line. So it's going down line by line. We can actually look at this documentation too. This is a class function, so we can look at it. Python read line function. I think it's a file handle function. So let's see, read line. Let me see. Yeah, it's in one of these here. I'm trying to find the primary documentation. These are secondary ones, which are kind of okay. But yeah, there's tons of functions we can use for file handles. File handles are, it's like a link. It's like a link to whatever we opened. Let me see. Oh yeah. Right. Let's come back into it. Let's talk about the importance of something called doc strings. Right. This is documentation that helps users understand how to use your function. For example, this is a doc string right here. This is telling the user how to use it. The cool part about writing a doc string is we can use the help function. Right? Remember there was a help function in Python where we can ask how to use something. So if we were to ask, hey, how do I use the function read first line? Right? It's going to return us the doc string. This is what we had earlier. Right? This is exactly what we wrote over here. Right? So we forgot to write a doc string for the power of function here. So just backing up a bit, we did a power of function here. Right? It would be a good practice to document this function, right? Like if I were to ask how to use it, right? Like if I said help on power of, right? Help on power of, this is going to say there's no help on here, right? It just repeats back the header. So it might be, it's a really good program practice to tell the user how to use it. Right? So I'm just going to put a docstring here. Now the docstring, once again, it's pretty much like copying this right here. Right? It'll describe its inputs and outputs, and also the purpose of the function. So let's do the purpose of the function, right? So the purpose is to calculate and return the exponential, return an exponential calculation. Right, that's the purpose. And then next we need to describe its inputs and outputs, right, which are typically described here, right? Inputs and then output. Okay, so I'll put it here as arguments. This is the inputs, and we have two of them, right? We have sig. This is the significand, which is the value to exponentiate. And then the second input is power, right? Power, this is the exponent. There we go. So we got the inputs, and then finally we should describe as outputs. Right? It might seem kind of tedious, but as our functions get more complex, this is necessary. Especially when you're writing functions for your coworkers. Right? Some coworkers might not be interested in reading the whole body of the function. They just want to see the English on how to use it. So returns, this is output, returns the result of exponentiation. Returns the result of sig to the power of the exponent. Right, there we go. We finished the docstring. Right, this is, once again, it's just a comment, just a multi-line comment. So if we were to ask for help on it, right, it would finally tell us how to use it. Mm-hmm. Yeah, scrolling up a bit. Yeah, so once again, the docstring typically has the description, the inputs, and outputs. All right. So hopefully people see the importance of a docstring. Okay, we just did this right here. Yeah, we just did this up here. Let's go down a bit. The help function, yeah, we just talked about that too, so I'm going to skip over it. Okay, and then here's another, I'm going to skip over this right here. Folks can read over this later. It's pretty much just a upgraded version of reading a line. Right? This is not too important yet, but a few lessons from now, we're going to cover this again. It's really just reading a file in a different way. Okay, so that's about it for now. I'm going to cover global variables and scope in just a bit. But I want to go back to the lab. Right? So let's finish the rest of the lab, and then we'll move on to variables and scope. So let's go ahead and open up the lab. We have a couple more things to do. It's going to help us out with a turtle. Okay, lab 10. We got all the way down to part 2 over here. Let's see, part 2. Let's spend like, I don't know, 10, 15 minutes writing this. I'm going to help folks with question 1. And then folks can probably do question 2. Okay. So in part 2, we're asked to write a function that draws a triangle. And then in the second part is asking us to use that function. So basically, this part, there's going to be a definition, and then the next part is going to be some invocations, meaning we're going to call what we just defined. Once again, this is probably the biggest hint for the RoboCat assignment. So let's help folks out with this. We might need to import something so we can use the turtle. So let me make another cell and import the turtle. I forget which line it is, so I'm just going to copy it from a previous one. Okay, here it is, copy, and then paste. Okay, yeah, go ahead and import this, because we're going to need to use this. All right. We kind of already did this earlier. If we take a look at the previous, at the lesson, the functions lesson, and scroll up a bit, you might remember we drew a triangle here. Here, let me import something real quick. Here it is. Yeah, at the top of this lesson, you might remember we did a triangle where we defined this right here. We defined a triangle as 3 move sets, and then we called it 3 different times here. So run it. We see that we created a new turtle, and then we did a triangle right here. Let me do this one at a time. All right, so let's just focus on this. All right, so we defined a triangle here, and then called it in the cell. Right, so we created a new turtle and invoked the triangle function. Right, so there it is. There's one triangle. Right, and then we can reuse this function over and over again. Right, like if we were to move it 100 up, right? You see, it moved up from the triangle, and then now we can draw another triangle. Right, and there it is. It drew another triangle. Yeah, and we can move it again. Right, so I'm just going to move it. Maybe let me turn and move it. Actually, let me turn it like -90, and then move it 100. Right, so triangle, triangle, and then it moves over here, and we can draw another triangle just by invoking the function again. Right, so this is going to be very similar to the lab exercise, but we're going to kind of upgrade the function. Right, so this function is hard-coded for a size, right, meaning that every time we call this function, it's going to be 70 pixels on each side. We want to have a little more control over the function. Right, so scrolling down a bit, you might remember we upgraded the triangle function here. Right, we rewrote the triangle function to have an argument, right, an input. So the sizes are no longer hard-coded. Right, basically, whenever we call the function, we can put in a number, which will tell us the size of the triangle is drawing. Right, so here, if I were to redo the triangle function, right, there it is. I just ran that cell, and now we can specify the size of our triangle. Right, so if I did a triangle of size 80, right, this is 80, and I can make it bigger, right, like 200. Right, you see that's much bigger. And then here I'll go like 10. Right, we can't see it, but it's there. But yeah, we're going to use this triangle function pretty much. Okay, so let's go to the lab and finish this right here. I'll help folks get started on number 1, and then we'll give it like 10 minutes for folks to do number 2. So let's write that triangle function. Right, so write a function to draw a triangle. Okay, so right away, we know the name, right? It's called triangle, right? So we can define something called triangle. There we go. And then it says takes one argument, right? Length or size. I think there's a typo here. I'm gonna go ahead and change this cell. This should have said size. It actually doesn't matter what the name of this variable is, but I'm gonna make it consistent. So size, and run this cell. I'm just trying to make it consistent with this doc string down here. Okay, when one argument size, so boom, we have one argument called size. Okay, and yeah, there it is. There's our function header. Right. Once again, it's a good practice to write the docstring, right? And in the midterm, this is required for minimal credit. Right? Writing the docstring will help us understand what it's doing. So we're going to do the purpose, the inputs, and outputs. And so here, the purpose is to draw a triangle of specified size. Yeah, exactly. Draw a triangle, and then let's do the inputs and outputs. So arguments. We only have one input, which is size, the length of a side. Okay, there it is. And you know what? We don't have an output. This triangle function doesn't return anything. It doesn't produce a value that we can capture later. So yeah, there's no outputs. Right? All it does is it draws a triangle, but it doesn't return like a result of a calculation or something. Right, so that's it. All right, so let's help folks get started on this. Right, it's going to be exactly like the lesson. Right, in the lesson over here, you might remember. Right, there's 3 move sets. Right, move, turn, move, turn, move, turn. Right, same thing. So let's try that out. Right, so we're going to use this argument here. Right, probably the turtle will move, tu.move, and then size. And then if we're drawing an equilateral triangle, I think we're going to turn it by like 120 degrees, I believe. And then tu dot move again, right? It's just going to be this copy and pasted 3 times. Okay, there we go. So we defined a function. Let's go ahead and invoke it. Right, the next part asks us to invoke it some amount of times. Right, so if I were to say triangle, oh, you know, I need to do a tu.new, right? Because if I did triangle here, it's let me go triangle 100 or 50 actually. Right, it doesn't show anything because we forgot to create the canvas. So tu.new, there we go. We created the canvas, and we should see a triangle there. Here, you know what? I'll help folks get, yeah. Oh, okay. Yeah, I'll scroll up a bit. Oh yeah, the indents here, they're I think it's a tab or 4 spaces. Yeah, these indents are important. If it weren't for the indents, then they wouldn't belong in the function. Oh, this is just a definition, but we're gonna call the function down here. We're gonna invoke it. So yeah, once again, this running this cell does nothing, right? But it does load a function into the Python kernel that we can use. So we're gonna use it down here. So I'll help folks get started on this real quick. Right, so we called the triangle of size 50, but you know the triangle is facing the wrong way. The reason for that is because you know when we start a turtle, it's looking north, right? So it's looking north, but then when it calls the function, right, it moves and then turns, moves and turns. So you know maybe it might be necessary to rotate the turtle first, like tu dot turn negative 90, right? So I'll rotate it this way. So when we call the triangle function, it should be an upright triangle, right? Because the triangle function will, the first thing is it'll move it. Right, so there we go. We'll run it, and we see it, triangle in an upright position. All right. So I'll help, let's give it like 10, 15 minutes. See if you can make this right here. This is like, for folks who have played Zelda, this is some emblem in Zelda. Anyone here played that? Yes. Yeah, the Triforce in Zelda. Yeah, we're pretty much drawing this right here. Yeah, give it a shot. 10, 15 minutes. If you can do this, the robot cat assignment will be pretty smooth. All right. I'll give it 15 minutes or 10 minutes actually. Okay, welcome back from intermission, folks. I hope most of y'all were able to do this. Once again, if you're on the recording, please try it out yourself before copying this down. It'll help out the problem solving process a lot more. So currently we have just one triangle here, right? We need more triangles, right? So the turtle moves, moves, and then turns again. Right? So we just have to move it into correct position now. Right? In this case, since we're dealing with size 50 triangle, right, we could move it 50. Let me zoom in a tiny bit. Yeah, there it is. Drew a triangle and then move 50. Right, we can draw another triangle. Right, so a triangle of size 50 again. Right, see, there we go. And then now we just have to move it again. Right, it's up to folks however you want to do it. But in this case, we need to move the turtle over here. Right, we need to move the turtle over here. This way, we can draw a triangle like this. Okay, so I'm going to move the turtle up here. You can do this however you want. I'm just going to do some turns and moves. All right, like tu.turn. I think it's 120. There we go. Now turned, and then let's move it up 50. Tu.move 50. Okay, there we go. And now we just got to rotate it again. So tu.turn. I'm just going to rotate it counterclockwise by -120. I mean clockwise. There we go. Now it's facing the right orientation, and we can finally call the triangle function again, right, which should complete it. All right, triangle of size 50. And there we go. Triangle of size 50. Cool. Hope folks got this done. If you got this done, the next assignment should be pretty smooth. All right, so I'm just going to pull it up again. I have it over here already. Robot cat, right over here. Oh, you know what? I think I misspelled this. HTML. Oh yeah, there it is. Yeah, so it's pretty much going to be the same thing, right? Draw a robot cat, right? But we're going to use a couple functions. Right? We can reuse the triangle function, right? So the specifications of the program here says, hey, create two functions. Right? One is going to be called triangle. Right? We just did this. And then write another function called square. Right? So once you finish those two functions, you should be able to invoke them and draw a robot cat. Right? In particular, there should be maybe 10 functions calls. Right? Not 10 lines of code. Right? 10 function calls with some moves and turns in between. Right? Because there are like 10 shapes here. Okay, hope folks are cool with this. Yeah, functions are cool. Really cool. Yeah, Lisa.
Yeah, I don't know if I'm missing something, but mine's not working.
Okay, do you mind sharing your screen? We could take a look at it.
Yeah, let me do that.
Okay.
Um,
Yeah, what's not working about it?
okay, so I was supposed to import the turtle, right? Right here.
Yeah, you're good.
Okay, I did that, and then I did all this,
Uh-huh.
and then I think I have the same code down
Oh
here,
yeah,
but
so that first line is a function call, so it has two parentheses after the new.
oh, that's
So,
what I'm missing. Oh, shoot.
yeah, otherwise it doesn't properly invoke the function.
Right. Oh, hello.
Nice.
Okay, I'm good.
Cool,
Thank
cool.
you.
Yep. Nice work.
Thank you.
Yeah. Okay, so yeah, functions are cool, right? We're able to build a Lego, right? So we built the Lego here and then we called that Lego a few times. Right? And also, someone earlier in class Someone in Zoom chat says use the coordinate system. Yeah, you could totally use the coordinate system too, right? Instead of moving and turning manually, right? It's up to folks however you want to do it. There's so many different ways. So someone in class earlier brought up how functions can kind of be related to the industry, right? So you can think of this import statement as a library of functions that we're able to use. Right? Someone wrote this library for us. Right? If you're curious who wrote this, it's actually a person named Mike Matera. Right? Mike Matera is the original author for these notebooks. Right? So right here, lifealgorithmic.com. Once again, I'm crediting a coworker. Right? This is the coworker right here that created the Jupyter Turtle library, and then we're using it. Right? So similarly, we wrote a function here. Right? We didn't write a library, but in future programming courses, you might find yourself writing a whole file, right? A whole big file that are filled with functions. So imagine a file filled with a bunch of functions, and in another file, you're going to import all of those functions that will let you use it. And so this is kind of like how the industry puts together code, right? Pretty much different coworkers are working on different libraries, and then another person is putting them all together, right, to build something. So it's pretty cool. Functions are really nice. And just for a sneak peek into functions, I do use functions. I use Python functions to grade my C++ class, actually. So if you're curious, I can just pull it up real quick. I use Python. Let's see, cd, cs11. You don't have to know this. This is just terminal commands. So I have an auto grader, which is pretty much a bunch of Python scripts that grades student homework. Right? For example, the last homework they did was called, let's see, BMI calculator. You don't have to worry about what that is. But we have a file here, right? This is a file called grade.py, right? This is a Python source file. Right? So if I look into the grade.py and look at the very top, right, you see how there's a bunch of imports? So I'm using a bunch of statements to grab functions from libraries, right? This autograder is using a bunch of functions from other people's code, right? These are just standard libraries, by the way. Right? And then so if I look down my code, right, this is all Python stuff, right? See, like, for example, I just defined a function called check zip name, right? This is just checking to see if they named their file correctly, right, given a file name. Right? And we haven't covered if statements yet, but this is saying if they named it incorrectly, then there's going to be a deduction of 2.5 points. Right? And then there's some more stuff down here. Right? Here's another function, right, that checks another thing. And then check compilation. You don't have to worry about this. But yeah, you see how many functions I have? Right? I have a bunch of Legos, and they're going to be used somewhere in something called a main. Right? So in Python, in classic Python programming, there's a main, right, where we invoke all of the functions, right? We call the functions that we just wrote. Right? So this is kind of programming in the future. You're writing files, right? For now, we are kind of just playing around with a Jupyter notebook. We're writing small blocks of code and pressing the play button. In the future, maybe after the midterm, we'll talk about classic Python programming, in my opinion, right? Classic meaning we're writing source code and we're running the whole thing. Right? But for now, Jupyter Notebook is good for kind of visualizing things and pressing play on small blocks of code. Yeah, functions are great. Yeah, trust me, it's really good stuff. Okay, we just finished the rest of the lab. So let's go ahead and finish the rest of the lesson. Right, we got all the way down to something called scopes, right? Function scopes. So I'm going to scroll down here. Okay, function variables and scope. All right. I'm just going to deviate away from this notebook and kind of make things a little more concrete because these examples down here are a little hard to understand. So let's just start from scratch, right? I'm going to load up a brand new notebook, or not the brand new one. I'm just going to reuse this sneak peek from a couple of days ago. A couple of days ago, I did a sneak peek that gives people a high-level overview on what functions are. So just think of this as a brand new notebook. Okay, so let's talk about scopes. Right? Let's say we define a function. I'm just going to call it like a foo. Right? It doesn't matter what you call it. So I'm going to define a function called foo and create a variable in here. Right? Initialize a variable. So I'll create something called like text is equal to hello. Okay, so just a very small function. Right, I'm gonna go ahead and run it. Okay, cool. We ran it. It didn't do anything yet because we never invoked the function. Right, so we do have a definition. Right, what do you think is gonna happen if I print text? Right, let's see. Right, I mean, we did define it up here. Right, but let's go ahead and try to print it out. Right, it gives us an error message. It says text is not defined. Isn't that weird? Right, I mean, we did define it here. Right, but folks might be wondering, oh, you know what? We need to call the function, right? Like maybe we need to say foo, right, which will invoke this upper function. Right, and just to prove that we are invoking it, I'm going to put a print statement here. Right, you don't have to do this. I'm just going to say initializing text. Right, just a debugging statement. Right, so I'm going to go ahead and run this now. Okay, cool. So we defined a function, and then we invoked it. Right, so now we should have a variable called text. But if we print text out here, right, let's see what happens. So I'll print it, and it gives us an error. It says text is not defined. It is defined here, though. Isn't that weird? So this is a common pitfall in functions, right? There's something, in programming, there's something called scopes. This is a string that only exists within this function. Right, so when we try to access outside the function, it's not there. Right, so once again, let's try to do this. So we called foo, right? We enter the function and initialize a variable called hello. Right, so this does exist. Right, so if I were to print it here, inside the function, text is text. So let me make this an f string. All right, let's keep this simple again. Okay. So we define the function. I'm gonna invoke it. Okay, there we go. All right, so you see how inside of the function, right, text is hello, so it does exist, right? But the second we try to access it outside of it, right? So let's say f string outside the function, text is text, right? It errors out, right? It's erroring out on this line. So this is a concept called scopes. Right? Scopes define the lifetime of a variable. Right? In this case, where the function scope is defined by this body, right? Everything that's indented within the body is in a local scope. So when this function ends, right, the function ends after this print statement. The lifetime of this variable is gone. Right? We forget it. Right? So that means that here, when we try to access it, it doesn't exist. Right? So this might be a little confusing, but this is it's called scoping. Right? And people might try to fix this, right? Like let's say I create a variable called text equal to hi. Okay, this is gonna be a tiny bit tricky, right? What do you think it's gonna print? So I initialized text to hi, and then I call foo. Right, so we're going to invoke that function, go into here, and then set text to hello. Right, and then it should print hello, but then let's see what happens on this third print statement. Right, yeah, I should say hi, exactly. Yeah, nice guess. So yeah, these two texts are different, right? Because they're in different scopes. Right? This text right here is local to the function, and this right here is technically global, right? It's local to the global scope, where everything can kind of see it. A little tricky, right? Yeah. So there's a lot of little tricky things we can talk about, but yeah. When we start categorizing the functions, this could be considered spaghetti code. Yeah, this is considered spaghetti code because things are kind of tangled, and for the reader to kind of interpret this can be hard to interpret. So this is a kind of a bad program practice to have the same names in different scopes. All right, here, let's make this a little more confusing, just because this is a very common pitfall, right? What if I put? Let me comment this out and see what happens now. All right. So I just commented it out. This text is equal to hello, right? I've deleted it. All right, let's see what happened. All right, so we have a definition. Right? Nothing happens here. All right, so once again, let me just prove it. So just kind of take this step by step. Made a couple changes. Right? We defined a function, right, but we didn't call it yet. So let's go ahead and call it. Right? But I'm going to initialize this before calling it. Right? So text is equal to hi, and then foo. Right? Let's see what happens. Okay, cool. So we see that this function does have access to the global scope, right? Meaning that it can kind of see variables outside of it. So this is a little tricky. Right? This function is using this right here because there's no local ones in here. Right? But once we define a local one, then it'll use the one that's closest to it, right? The closest local one. So now it's going to print hello, right, instead of hi. Right, so this might be a confusing example. The reason why we're talking about this is to kind of avoid spaghetti code and kind of like global variables. Right? Spaghetti code is when things are kind of entangled within each other. So earlier, this example is borderline spaghetti code, right? This one is borderline spaghetti code because we're accessing something called a global variable here. Okay, so yeah, be careful with this type of stuff. Okay, just to do another example. All right, let me just think of another one. Oh, okay, let's talk about function arguments. So I'm just going to make another function called bar. Right? It doesn't matter what you call it. Let me just put like something in here. It doesn't matter. And let's just say, let me just print it. Print something is something. Okay. There we go. We define a function. Right. All it does is it prints out the input. Right, so I'll put bar, and then let's say Andrew. It doesn't matter. Right. Basically, this string gets substituted into here, so we should print out something is Andrew. Right, so this doesn't matter too much, right? But a common pitfall here, right, where people can kind of do spaghetti code is where they'll use the same variable name, which is kind of confusing. So this is going to look confusing, right? Like I'll put something is equal to tac. All right. Let's see what it's going to print out. Right? We define something, right? But then Andrew gets substituted into here, so it's still going to print out Andrew. Right? Even if I define it here, whoops. Right? So even if I define it before the function, it's still going to print out the same thing. Right, so once again, this might be kind of hard to read because it's borderline spaghetti code. But yeah, hopefully people kind of see what scopes are. Scopes define the lifetime of a variable. Exactly, yeah. The scope here is everything in the function body. Mhm. Everything that's indented. So if I have something here, another thing, right? This, I'm just gonna say equal to 5, right? That this only exists within this function call. Yeah, exactly. Yeah. Yep, exactly. It goes as long as you want until you redefine it. Yeah. Okay. Let me. What is bar? Oh yeah, good question. This is just a random name. It's like saying X Y Z. In programming, they have foo bar baz, foo bar baz instead of X Y Z. Yeah, it's just like random names. That's all it is. Oh yeah, yeah. You can call this whatever you want. You can call it X, and call it X. Yeah, you can totally. Yeah, yeah. This is literally like algebra. We're making functions. In algebra, functions typically take an input and then produce some output. All right. Anyways, moving on. We just wanted to talk about global func variables and scopes. I'm going to skip over these parts down here. They're a little hard to read, but I hope this was a little more interpretable. If this wasn't that interpretable, you can take a look through here. But for now, you can kind of think as global variables as being a bad program practice, right? So hopefully people are cool with functions for now. Once again, I'm going to skip over this stuff on the bottom. They're not too important yet. Uh, but yeah, feel free to take a read through it. It's pretty much the same thing as we did over here. Okay, I think that's about it for functions. All right. Okay, cool. So we finished functions. I highly recommend practicing more and more functions. In a couple of weeks, I'm going to have a practice midterm that's pretty much asking folks to write a bunch of functions. If folks want more practice, you can look it up too. Like maybe you could look up Python function practice. Right? There's also textbooks. If folks don't have textbooks, then you can look at these secondary resources. You can think of this as LeetCode. Right? LeetCode is like interview questions, kind of interview questions that kind of filter out the first part. So right here, it'll say write a Python function to find the max of 3 numbers. Right? So you could practice that. Write a function to sum all the numbers in lists. This is also a good practice. So, practice this. These are really good for functions. Oh yeah, exactly. You don't have to look at this right here. This is just primary documentation that talks about native functions that come into Python. Yeah, exactly. Oh, I just googled up Python function practice. Yeah, I'll have a practice midterm out. That's going to be a little more concrete. But yeah, I do want to stress how important functions are and making sure folks can implement one. Okay. Okay, so that's about it for functions. Let's see, we have about half an hour left in class. In the beginning, I did say I was going to make a optional video on how to do the HTML weather. You know what? Let's just do it now. This way I don't have to record one tonight, and this way folks don't have to wait for it. So with the remaining time, let's get a head start into the HTML weather assignment. Yeah, all good. Okay, so yeah, once again, the HTML weather, this is due tomorrow, and then we have a robot cat due next week. All right, we're gonna, folks should be able to do the robot cat by now, if you can do the square and the triangle functions. All right, but let's back up a bit. All right, let's back up to the HTML weather. There wasn't as much hints on this, so let's go over it. So I'm gonna load up this HTML weather over here. You know what? I'm gonna wait like 5 more minutes. Let me wait 5 minutes just because someone is gonna be right back. So I'm gonna pause the recording here and be right back in 5. Okay, let's jump into some head start for this project due tomorrow. Once again, this is the same as the previous one, but we're gonna make it look nicer. The previous one was acts as a dictionary to print out the weather, but now we're going to format it into this table of 2 columns. All right, I'm gonna ignore this first row for now because this is a tiny bit harder, but let's pretend like we're doing the table from here, right? Temperature, and then high, and then low, and humidity. Okay, we'll focus on this graphic in just a bit. All right, let's get folks started. So the requirements is we must put a HTML in a variable called myHTML, right? This is a string that's going to represent the table. So I highly recommend revisiting this previous lesson, right? We're going to be doing this right here, right? In the HTML lesson, we're going to be pretty much doing tables. Right? It's going to look just like this, right? Same thing. Okay, so let's start this. Right, we have some code here that once again, all it does is it downloads the data from the internet. Right, so I'm going to run this function. Right, so this function will allow us to download it right here. Okay, there we go. So we can call the function here. Right, this line of code will download the data. So I'm going to go ahead and run it. Okay, once again, this downloads the data. It's a function that is already provided to us. Right, oh, let me change my name here. Okay, there we go. So I just ran the cell, right? Meaning we downloaded the data. Right? You might remember this from last class. This weather is a dictionary, right? It's a data structure. Right? You can visualize it by making another cell, or just to visualize it. If I put weather here, this is going to tell us what it looks like. It's a dictionary of key and values. So we're going to grab these values and put them inside of an HTML table. So we should probably declare a string that will represent the HTML. Right? So the part of this requirement up here in number 1, right, says you must put your HTML in this variable. It must be called this because there's an auto grading cell at the bottom of the page that confirms this. Right, so we need to make a string called myHTML. Okay, and then what else? And then it must contain a table with 6 rows. And then, yes, the same requirements as previously, except with an icon. Right, we'll talk about the icon in just a bit. Okay, let's get the string started. I recommend using a multi-line string. The reason why is so we can read easier, right? We can read things easier on multiple lines. So there's our multi-line string. I recommend making it an F string because we need to interpolate some values into the string. All right. So we need to create a table, right? Like if you take a look at the previous lesson, the way to create a table is with these tags, right? Like it's the table tags. So table, and then the ending tag, the closing one, I mean. Okay, there we go. We have a string that has an empty table. So let's go ahead and run it. Okay, we just ran it. It doesn't do anything, but it makes sense because we never displayed it. So let's go ahead and display it, right? We need to convert it to a HTML object, right? So HTML object, convert the string to this object, and then now we can display it. All right, let's test this. So I'll run this. Okay, I just printed out an empty table. Right, it's right here. There's nothing here. Makes sense. Let's start it. I'm gonna look at the example up there to see what we need. Okay. So there are 2 columns, right? In each, and yeah, in a bunch of rows. Now, I'm gonna ignore this icon for now. All right, let's pretend that we're printing the temperature. All right, so let's make the first column, first row, I mean. Okay. So if you take a look at the previous lesson, you'll see that TR, the TR tag stands for table row. So I'm gonna make a new row, right, called TR, and then the ending one, TR. So now we have a table with 1 row. If we go ahead and run it, it's empty, right? which again makes sense because there's nothing in here. So this row is going to have 2 data elements. And the data, 2 cells, I mean, right? Each row has 2 cells. Right, so let's scroll up a bit. Right, so this row has cell 1 and then another cell here. So these can be represented with the tag TD. Right, so this is going to look a little confusing because it's going to be on 1 line, but I'm going to format it in just a bit. Right, so we have a row. Let me zoom in. We have a row with 2 cells. Right, so I'm going to go here, /TD. So this is like 2 cells right here. They're enclosed within each other, right? The table row, and inside of it, TD for table data. Okay, once again, this is hard to read. I'm going to format it in just a bit, but hopefully people see that, right? This is a table with 2 cells. Right? 1 cell is here, and another cell is in here. It would probably be easier to read if we nest things. Like if we see the table row is here, right? And so each table row is nested with 2 table data elements. Like this is arguably easier to read. This is saying here's 1 row. One row has 2 cells. So we need the first cell to say temperature, right here. We can just type that in. Right? The first cell has temperature, and then the next cell over will have the value that we grabbed from the dictionary. All right, so let's do that. So we can do temperature, and we can put temperature in here, and then the next cell over is going to be some number. Right? I'm just going to hard code a number here temporarily. Right? I'm just going to put 100. Don't type in this 100 because we're going to replace this with the actual data in just a bit. I just want to check the table out. Okay, so I'll go ahead and run it. Okay, there we go. You see how we have a row with 2 data items? And that's what it looks like. And let me just hard code another one, right? And by the way, I'm going to replace this 100 with something else in just a bit. Okay, so the next cell, row, I mean, is going to be high, and then another number. So let's get that in. Another row. Okay, so scrolling down a bit. Okay, so I'm going to make another row. Right, so table row and then the closing tag table row. This row is going to contain 2 columns again, right? 2 cells. Right, so table data / table data, and another one / td. And this is going to represent the high, right? So I'm just going to put high, and then I'm just going to make up a number like 150, right? 150 Fahrenheit. Okay, I'll fix this in just a bit. Okay, we just added another row, and let's run it. So I just press play, and you see our table is being built. Right, we got temperature 100, high, and then it's 150. These are hard-coded numbers. Let's unhard-code this. Right, this is if I see any hard-coded numbers in your HTML string, it's going to be a deduction. So it's because this needs to pull from the weather dictionary. Oh, hard-coded means that it's going to be the same every time you run it. So it's not always going to be 100. It's going to rely on data here. Right, so what do we put in here? We have an F string. Right, so we can interpolate something in the F string. Right, so you're going to have to take a look at your previous assignment for this. Right, but pretty much we're pulling a value from the dictionary. Right, in particular, we're going to pull this temperature value. Right, so the temperature key will give us this number. Okay, so let's do that. So we can interpolate that dictionary value in here. Right, we can just say weather and then put in the key. Right, there we go. And let's run it. Okay, so let's run it, and we should have temperature. Right, this is not hard-coded anymore. It's being updated from whatever we downloaded. 285. This is not Fahrenheit. This is in Celsius. I mean Kelvin. So we need to convert this to Kelvin. You can do that straight into these interpolation curly braces. I forgot what the conversion is. Let me see. There's a link. Here it is. How to convert. The Fahrenheit is equal to Kelvin times 9.5. 9 divided by 5, I mean, minus this. Okay, let's try that. All right. So yeah, we need, this is Kelvin. Right? Inside of the curly braces, we can work with that variable. Right? We can go ahead and convert it. Okay, there we go. So it should be in Fahrenheit now. Just like our previous assignment. Okay, let's test it. So yeah, I just ran the cell, and there we go. You don't have to worry about these 0.9999 here, but this should be the Fahrenheit right now. And it's pretty cold, 54.2 degrees in Aptos. So yeah, that's the first row. Right, if folks are wondering how to get rid of these 999s, oh, can we go over how to round? Yeah, someone in Zoom chat asked how can we round? There's a couple ways we can round this. There is actually a function called round in Python. Python of built-in functions. I believe there's a function called round. Let me check. Yeah, there's a function called round here, which pretty much takes a single input and then rounds it to some precision. Right, so it takes 2 inputs. The first is a number, and then second is the precision. Right, so if we were to apply this, it's kind of like saying, let's say pi, right? Let's say 3.14159. Right, let's say we want to round this. Right, you can put it inside this pre-built function. Right, round to 2 decimal places. Right, that should give us 3.14. Right, so we could use this function. This is just one way. Right, there's tons of other ways too. I feel like this is the easiest one though. So we could use that. Maybe we could round this whole thing to 2 decimal places. Right? So there's 2 arguments here. Right? Inside of the round function, there's this first one, and then the second argument is the precision 2. Right? This is a little hard to read, but yeah, we're rounding this number to 2 decimal places. And yeah, it should round it. Once again, this is just one way. There's another way too, but I don't want to get into it. It's pretty much using a formatting specifiers. Okay, hopefully people are okay with this. So with that in mind, you should be able to do this next part right here, this high. Right, so make sure there's no hard-coded numbers. It needs to pull from the weather dictionary. Okay, what else? There is a 7-day forecast. Say what? Oh, I'm running this cell by pressing Control Enter. Right? Control Enter is just the shortcut to run the selected cell, but don't go to the next one. Yeah, it's pretty much saying press play, but don't go to the next one. Little keyboard shortcut. Control Enter, yeah. Okay. Yeah, just use the play button for now. Yeah. Okay. So let's see what else we need, right? Hopefully people can do the rest of these rows. This 7-day forecast is a tiny bit trickier, but if you did the previous assignment, you should be able to index a list correctly, right? These are indexed within a list, right? In particular, this is in one cell, by the way, right? So this is one row with 2 cells. This right here is going to use something called breaks. Right? So I highly recommend looking at the previous lesson, and there's a thing on breaks right here. Right? These BRs, it's like pressing enter. So you're pretty much going to be using these breaks within a cell. All right, so give that a shot. Let's go over one more hint, the arguably hard part of the assignment. The first row is a picture. Interesting, right? Like, where do we get this picture from? Well, let's see. Let's see. The weather dictionary has a link right here. Right, you see how one of the key value pairs contains a link? All right, let me click this link, see what it is. So I'll click it, and we have, it's sunny right now. For folks here in person, it's sunny. It's probably going to be different tomorrow. Yeah, it's raining tomorrow. So if you were to rerun this cell on a Thursday, then this link will be different. It might be a cloudy or it might be a raining icon. So we need to use this link to display an image on the first row. So this is going to be very similar. I'm going to refer back to the lesson again. Right, going back to the previous lesson, you might remember we did something called an image tag. Right? An image tag lets us link a source and it'll display it there. Right, so pretty much we're just going to use an image tag. Okay, let's help folks out with this. So I'm going to create another row. Right? Our very first row needs to contain the icon. All right, so I'll make another row at the beginning, tr, and then a closing one, /tr. This is going to be the first row. It's going to have 2 table data elements, 2 cells, td, /td, and then another td. Right, the second cell is going to contain the image tag. All right, we'll do that in just a bit, but let's do the easier one first. Let's do the first cell. Right, this first cell is going to be here. It says rain. Whoops. It says rain, but you don't want to hard code rain in here, right? This is a value from the dictionary. All right, so we're going to get a value from the dictionary and then the link from the dictionary. All right, so let's see where rain came from. Right, if we take a look at the dictionary, that probably came from the title. right, that represents the current conditions. So we can grab it from this key title. Now let's do that. So here, I'm going to interpolate the value from a dictionary, right? In particular, the title. Right? This is going to give us a value. Okay, let's just test this real quick. So enter. Okay, so we got the first cell, right? It says clear, but now the next cell needs to have an image. Okay, so let's help folks out with the image. The image here is the tag image, right? This is a special tag. It doesn't have any closing ones, right? It's just an opening one. So we can go ahead and use something like this, right? It pretty much says image, and then source is equal to some string. So let's go ahead and apply that. Where is it? Oh, over here. Cool. So the image tag looks like image, right? And then source is equal to some string. And once again, I'm referring to the previous lesson. Okay, what do we put inside the string? We got to get this link somehow, right? Yeah, we need to put this link. Yeah, we do need to pull it from the weather, right? So once again, you don't want to hard code this. Right? If you hard code this link, so please don't do this. Please don't paste this link right here, because then it's always going to be clear, right? If we run this notebook in the future, it's always going to be clear. Right? We need to make sure it pulls from the actual dictionary, right? Because this link will change. Right? Tomorrow, this is going to be different. So we need to grab from this icon. Right? Remember key values? We need to grab the string that comes from this icon key. Hopefully people see what to do here, right? In here, we're going to interpolate the value from the icon key. Because this, yeah, icon, right? Here, let's talk about what icon does, right? If I index the icon here, right, this returns a link. So, yep, pretty sweet. It returns its value, right? Which is going to change if we run it again in the future. So there we go, and then run it, and we should have the first 3 rows. All right, I hope this gives folks a head start into the HTML assignment. You should be able to do the rest. The last part is a little tricky. The 7-day forecast. You want to make sure these 7-day forecast is in one cell. So yeah, you want to use the breaks, the line breaks, which is in this previous lesson over here, BR. Okay, with that in mind, let's see, we're ending just on time. Okay, it is the end of class right now. Cool, that was very productive. Let's do some closing thoughts. Let's see. Okay, we just finished functions. Make sure everyone's comfortable with it. Everything in the future is going to build on functions. Next week, we're going to do some fancier stuff. This is going to fully rely on us understanding functions. So make sure to try to get the functions done, understood by the weekend. And we're going to have a midterm in a couple weeks. So we're on week 5. So we're going to cover one more thing next week. And then the next week is going to be some catch up. And then finally the midterm. I'll have a practice midterm in next week. Okay, other than that, thank you all for coming, and hope you all have a great Wednesday.